Okay, it seems like everybody is okay with Friday from 2 to 3 p.m. as the extra office hour. For those of you who received my notice about specifying your preference for extra office hour, please complete the survey. I'm going to announce the office hour soon. Okay, but since like Friday 2 to 3 p.m. is one of them. Okay, for the other one, I'll confirm. I want to talk just very briefly about the assignments. I want to put into the big context why we are doing this. It's actually quite interesting what you're doing now. What you're doing is really the most intelligent part for the compiler. I'll put that into context in just a moment. Let me just talk very briefly for clarification. The way the TA will actually evaluate your submission later is exactly like this. For example, for one of the test cases you were given under the tests, if you open that, okay, that's what you were given. Okay. So you can see that in order to create, for example, the epsilon NFA, number one, do not rename or change the header of any of the methods. Do not do it. If you do it, so that means when we actually run the same test cases, your code simply wouldn't compile, and then you got very low marks. Okay, that's easy for you to follow. Okay, that's number one. Number two, let's just run this particular one just to make sure you know the process. Okay, if I simply run, I already got my solution loaded. Okay, and then if I run it, for example, for this test, if I say execute, okay, so let's say for this particular one, make sure you follow the correct step. So this one is saying we have some input epsilon NFA, and then we got as output some DFA. So how do you test it? Unfortunately, for this assignment one here, we are just doing some manual testing. We could have thought about maybe a better way if time permitted, but that's okay, just for now. Let's say I'm going to copy the output from your program just for the input. Input is epsilon NFA. I'll copy that. I'll copy that in just a moment. And then you have to stick to this particular website. All your programs should generate valid input for this particular program. Okay? I'll talk about the flow, and then I'll talk about the context. So if I go to that particular website here, okay, if I go there, okay. Okay, there's a website here. Go to input automation here, and then I will first of all go back to my output here. So this is one of the output from the input. And then if I go there and I simply paste it. Oh, sorry, didn't copy that correctly. Let me do it again. Let me do it explicitly. Okay, copy that, and then if I try to paste it, and then now, if as soon as the TA copy your output into here as the input, if they already show you, for example, some errors. For example, for some reason, your output did not actually put this greater than sign, for example. And then it's going to say error, which means it did not satisfy the specification. All your program's output string should be a valid input for this particular tool. It's more like a pipeline. Okay? Okay, in this case, it should be greater than. And if I say create automation, and this should be this particular, right, input that's visualized here. Okay, what do I really mean in the assignment instruction by saying you want to focus on the structure, but not the names of the states. For the names of the state, it can be arbitrary. Maybe for your program, for example, rather than having Q0, Q1, Q2, and Q3, let's say instead you have maybe S1, S2, S3, and S4, for example. However, the transition structure and also the way states are related to each other are the same, then that's considered as acceptable. Okay, just want to make sure you understand that part. Okay, okay, I just want to run it together with you, just make sure everybody's okay. Okay, any quick question I can answer about assignment, just go ahead. Let's limit to a few minutes. Okay.
Test cases is what you gave us is the same test cases.
Oh, basically, okay, how do we evaluate? So when the TA evaluate your submission, first of all the test cases we gave to you, we'll run it first to make sure at least you satisfy the basic requirements. And then we're going to run some additional ones. Okay, but I give you a little bit of advice. How can you create some additional test cases? For those of you who already play with the website, you will see they got a function called generate random NFA or generate random ENFA. You may want to try that. Right? For example, you can generate this guy over here, and then that can be an input to your program. And then to try to see if the corresponding DFA is really correct. How do you make sure it's correct? You may have to do a little bit paper calculation. I try to Google around to see if there's any other tool to convert from ENFA to DFA. I don't really have too much luck. If you do find one, please let me know. That can also benefit everybody. Okay, but at least when I did a quick Google search, there's no fast way to do it. Any other questions? Yes.
You have to consider that
I would say the shape of the DFA that's produced should be follow exactly the same procedure that we did in the class. So whether you have a dead state or not, it should not be a question. As long as the subset construction procedure generates some state that's equivalent to dead states, then you are fine. Okay.
So
Raymond.
I'm putting some states, but like the names are ugly. They're in brackets, and it's Q0, Q1.
Oh,
bracket.
I have another little bit.
Something like that.
Good. Okay, what Raymond is saying is this. No worries. Wow. Okay, guys. Okay, first of all, let's understand what the problem is. As for the solution, I don't think I should really tell you how you can solve it. It's quite straightforward. Let me just give you one more. Let me open the text editor. Yeah. Okay, let's say this. What Raymond was saying is like this. For example, there is a section called transitions. And then, for example, a valid one would be Q0, and then maybe you have maybe epsilon, and then it goes to maybe Q1, for example, right? That would be a valid one. What you're asking was, according to the subset construction, you have to somehow, maybe Q0 should be corresponding somehow, maybe the epsilon closure be Q0, Q1. If you simply do this, it's going to be considered as invalid, okay? How about this? What it is expecting over here is some kind of identifier. Or in some way, is it possible for you to have some systematic naming procedure in your program so that you are saying every time I have this, it should be called certain name? I think that's enough hints there. Okay. Raymond, I hope you got it. Good. Okay, that's something just for everybody. Okay. Anything else? Yes, quick. The order, oh yeah, exactly. So in some way, we don't care quite much about exactly what you're outputting, as long as they can be loaded to the tool. And then when we visualize your resulting DFA, we see exactly the same structurally equivalent DFA. The TA will compare by eyes. If they see it, well, if TA see any discrepancy, they will tell you, and then you lose some marks for that particular test. Right? You are not expected to submit any test cases, but I would suggest you better test your code rather than me testing your code, right? That's what I usually tell students. Okay, yes. Okay, anything else? Okay. Yes.
I mean, the assignment is only 2.5%, but the quiz is 4%. Which is 15-minute assignment you can take.
I know, you know, I wouldn't think about fairness or not. It's more about learning outcomes, right? I think I definitely can achieve something in a class within 15 minutes using a programming assignment, right? I would say, you know, percentage-wise, you know, I would say 2.5 versus 4. You know, to think about what you're learning from this, right?
It's a 1.5 difference.
Hmm?
It's a 1.5 difference.
Yeah, just a marking scheme, right? Yeah.
But we care about marks.
You definitely care about marks. So I would say assignment, you know, that's why I gave you guys, you know, 2 weeks, more than enough time to do it. So hopefully you can get it perfect, I hope. Okay. All right. Okay, how about, yeah. The projects, I will, as I said in the syllabus, I'll give that to you either week 5 or week 6, definitely before the reading week. So you definitely got more than 6 weeks to consider, for sure. Okay, I want to talk about just one more thing, just about the related to the assignments. I want you to put the what you're doing for the assignments into context over here, okay? And we have seen this flow chart actually in the very first or second class. And at that point, maybe you don't really see exactly what I meant, okay? Think about what you're doing now, okay? Let me take your task number 2 as an example, okay? You have a package called FA, right? So all the DFA related classes are over there, right? So you got maybe epsilon, NFA. Also, you got DFA classes, right? These are the Java classes. So I call these the abstract syntax. abstract syntax, or you can call them the intermediate formats. Okay, so now, yes, Chelsea.
When you have your intermediate representation and it's being reformed from the compiler, is this time as well that intermediate?
Yes, in some way, yes. Yeah, you can think about what you're doing in this. Oh, thinking this way. You can see from the test cases over here, in the Eclipse. Sorry, let me just close this. You can see the way we run your code is from Eclipse over here, and then more precisely, for example, here. You can see the way we build the DFA or epsilon NFA is by creating objects. Rather than saying we let your program take a single file, and the file got like a Java syntax, for example, and then to build it. So we are omitting that kind of step. Okay? So for this particular case over here, let's think about this. You can think about what's really missing from this particular assignment intentionally is you might have something called concrete syntax. And indeed, you have seen some concrete syntax for this kind of a construct already. For example, you can think about what the website can take as output over here as the concrete syntax over here. You simply got different sections for the epsilon NFA. For example, you got states, you got initial, you got accepting. So this is one kind of concrete syntax. Okay? And what's more important, let me put it here. Okay? You can think about one concrete syntax is from the website. And then you just got different section. Maybe you got the states, and then you got other things, concrete syntax. And then you can think about one thing I might ask you to do, but I didn't, is to say, given this particular concrete syntax is a file, you can somehow load it to the abstract syntax. Or thinking this way, concrete syntax over here is more like a compile time, which means you're given the file. And the abstract syntax over here is something for you to build runtime objects, right? You can think about this more like a runtime. Okay, so far so good? Okay, so now, concrete syntax, they are called concrete because they're being very specific. So I might just say, I might design just concrete syntax 1. I might have another concrete syntax 2. That might look just completely different from concrete syntax 1. For example, I may make something like this. I'll make this up. Machine and give a name, for example, M. Okay, and then you might say some keyword. You might say the states equals over here, and then maybe you say Q0, Q1, and then Q2. And then you might say transitions equals, and then I also say you want to follow this particular syntax. Maybe you say Q0 by taking, maybe I would say E specify epsilon rather than $, concrete, right? I'm being very specific for this kind of syntax. And then go to maybe another set syntax, maybe Q1 and Q2, right, etc. The purple and the orange, they are basically different concrete syntax. However, conceptually, they are the same. So that means once I built this particular abstract syntax over here, okay, let me just finish this and then I'll come back to the orange part. So let's say you have this particular FA, and now what you're really implementing for task number 2 is to actually do the subset construction. And then over there, you just got to convert that into another intermediate format, which is in the same format. In this case, that will still be just DFA. However, the front end over here might be concrete syntax 2, which means given this, you can also load it to the abstract syntax. You can see there's a common abstract syntax, but you might get a variety of concrete syntax. That's the picture I would like you to have. Okay? So what you're really programming for this particular assignment is really the core part for compiler, which is given this particular intermediate format, which is syntax independence. And then you will just do the transformation over here. Once I've done this part, you can support many front end. Okay? Let's say one day, if I decide to say I want to go from syntax 1 to syntax 2, what should I change really? Specifically, precisely, Mahu. What should I change? Let's say today, let's say I start you guys with a concrete syntax 1. Let's say. Now, let's say next month, I say now, I don't want to support purple syntax anymore. I want to support the orange one. Just the parsing part. Specifically, you only change just this part. That's it. Do I need to change any of the blue part about transformation? I don't need to. So that's the beauty about the design. Okay, guys, I think there's something that's missing from the manual for assignment 1. I want to mention that in the class. Okay. So later on, when you do your projects, you want to understand that this part about transformation for the intermediate format is really the meat of your compiler. Okay. Any questions? Good. Okay, that's about the assignment 1. But of course, if you got any specific issue about Java or using Eclipse, you can talk to me during the office hour. Okay, I wouldn't handle that in the class. Okay, something I promise I will definitely do it properly, I hope. Okay, is this guy here. All right, let's just do it one more time. Okay. This is basically the final implemented code from our scanner, right? Based on some regular expression. Okay, I want to do it just one more time. Okay. Okay, this guy here. Let's say that's a regular expression, and then from there we know we come up with 3 tables. Okay, to implement your scanner. Okay, so we got token type, we got transition, also we got the syntactic category. For example, for S2, it will be the accepting states for our DFA. Okay, S2. Okay, that's for our register name. You can look back to the slides. So let's just trace the code a little bit just once more. Let me look at this particular input here, R241. Okay, what Ashkan asked me last time was about this particular line, if I remember your question correctly, over here. You asked me about why should we reset the stack over here. Okay, I believe we're going to do a tracing for this example right away. Okay, I believe the reason is for this particular input string, we want to return R241 as the longest match, as opposed to saying R2 should be the register name. That's kind of not long enough, because if we can expand the input character longer to match the syntactic category for register, we should expand longer until we cannot expand any longer. That's briefly speaking. But let's see exactly how that works. Okay, so you see what I'm trying to say here? Okay, this line here. But let's trace it. Okay, let's trace it. Then you will see exactly what I meant. It's quite subtle, but I think that's important. Okay, I'll try to be very careful here. Okay, so now we have basically different variables to keep track of. We got S0. So now we have something called states. Initially, it's simply just S0. Okay, we also got a word, which is what we have read so far, just empty. And also we got stack S. Okay, I'll draw it over here. Okay, initially just empty, but we're going to put a bad over here. You will see why bad could be useful in just a moment. I'll just put bad over here. And one thing I believe the textbook didn't really make it explicit. When we say reset the stack, you don't actually remove the bad over there. You simply remove everything except for the bad. You still keep it at the bottom there. Okay, that's something I want to mention. Okay, let's trace it quickly. Okay, so now you can think about this will be our input over here. We're going to read character by character, and also there's an implicit end of file. Let's say it's an input file. Okay, end of file at the end. So it's really 1, 2, 3, 4, 5 characters we're going to read. Okay, so now right before we start, we already got S0. Think about we're starting S0 over here. Okay, and then what's the current state? The current state is simply S0, which is not the error state. So it goes into the while loop. Okay, the next character to read will be R. Okay, the word is going to be expanded to just R. Okay, we're going to handle that. And now is the current states final states. Current state is simply just S0. Notice that we have not pushed that into the stack. I'm following faithfully with the code. Okay, only S2 is accepting states. So now apparently this one is going to be bypassed. And then we're going to push state, which is S0, into it. And now let's do some transition. Okay, when we do the transition, basically, first of all, the character we are handling over here is R. R is register. And the current state is S0. S0 by taking register, you get to S1. And notice that we don't push S1 just yet. Okay? So once we get S1, we're going to assign state to be S1. So now S1, not in the stack just yet. And then conceptually, you can think about after reading R, we'll now move to S1. Think of it. Okay? So now we go back to the beginning of the while loop over here. So now is S1 an error state? No. So keep running the loop. Okay? And then we're going to see what's the next character. Next character will just be 2 over here, and the word will just be expanded by the character. So R2. So now the important question is, are we going to read further, or we're simply going to return R2? That's the important question. We'll get there. And now the current state is simply S1. Is S1 an accepting state? Not really. Okay, so we don't clear the stack just yet. And then we're going to push S1 into the stack. And then if we do it, we're going to put S1 over here. Okay? That's what we have got so far. And then we're going to make some transition over here. So now currently the character is simply just 2. So 2 is a digits over here. So now we are currently in S1 over here, and then we're reading a digits. So we go to S2. Okay? So now S2 is now the states. And not in the stack just yet. Not there yet. Okay, so now after that, we're going to go back to the while loop. So now S2, is it an error state? Nope, keep going, okay? For S2, so now you can see now, question here, S2 is going to match as one of the accepting states, right? Okay, so now what we will do is we have to reset the stack. So what that means is we're going to, let me just do this, get rid of everything but the bad. And then we're going to push the states, which is S2. Okay? One moment. Let me finish this run. Okay? Once we have done that, and then I'm going to say, let's do a transition. So now, what's going to be the character to read? It's now going to be 4. Okay? It's going to be 4. It is 2, and then we got 4, right? So 4, I'm going to put it here, and then 4 is a character. So 4 again is the digits. So now we are basically in S2. And then we read the digits. So it's going to be S2 again. Okay? So now think about it's now just going to be S2 again. So now I'm right here. Okay, Chelsea, I'll take your question first.
Just make sure I'm tracing this correctly. So now we're at S2. It's the if statement because it's an accepting state. So now this where it says if state is an element of F.
Yes, F is all the accepting states. In this case, only S2.
So at that point, the stack now looks like that, and then S2.
Yeah, so think about the reset stack over here. So as I mentioned before, when you say reset the stack, S over here, it only reset only the normal state contents. It does not reset the bad. No, it does not. Okay? Okay, let's continue. We're getting something very important. Okay? So now, as you can see, the process keep going because we didn't really, or we're not simply satisfied just because we have already read R2. Okay, we got to keep reading. Okay? So now we were over here. So now the current state is actually S2. So when we go back to the while loop over here, so now that's not an error state, so keep going. And then the next character is going to be 4. Oh, it's going to be 1, sorry. Okay, S2 here, I forgot to put it. So next one is going to be simply just 1, the next character. So 2, 4, 1, okay, I'll put it. And now is the states right now and accepting states. It is, so I'm going to clear that again. So now the way to clear that is by remove S2 over here, okay? And then I'm still going to push the current state, which is S2. You can see the S2 I removed is from the previous character, but S2 is actually for the coming one, the current one. So I'll put S2 over here. So now after this, okay, I'm going to do some transition here. And then, so currently I'm reading 1. So let's do transition here. So now 1 is basically digits in S2, and then I'm reading digits, so now I'm S2. Okay? So it's going to be S2 again. Okay? So we're going to reach S2 3 times, for the 2, for the 4, and for the 1. Okay? So now let's go back to the beginning of the while loop over here. So now S2 is still not an error states, right? Keep going. maybe the final time. So now we want to do the following. What's going to be the next character? So after 1, we actually read S2. In the file, very good. So now EOF, okay? So now we're going to see the word is simply just going to be expanded by EOF. That's what we have read so far. And then, now, is the current state, which is S2, is it actually an accepting state? It is. So now we should clear the stack again. Okay? If you clear it, and then we're still going to push the current states. And the current state is just another S2, because we encountered that 3 times. I'm going to put S2 over here. Okay, you can now see the history. I'll make it complete so you can watch the video later, just for reference. Okay, we're getting there. So now, once we get there, so now how do we trace this particular one? So now, so the character we're going to read is now EOF, right? Current state is S2. And then we are reading EOF, which is other. For other, we got SE. Okay, it's our error states. That means the state has now become SE. All right, so now let's go back to the while loop, possibly the final time. It's not a state error states. Well, while state is not equal to error state, but now it is. So that means we're going to exit from the while loop. So now we go to this second while loop. This is the so-called rollback loop. So what do we do? You're going to basically keep doing the body of the loop over here until either states that we're looking at is actually an accepting state, or is the state is actually equal to bad, right? De Morgan. You want to do until the negation of the state condition is true. Until it is false. Okay, so now for the first one, you can see the state currently is simply error states. Okay, so I'm going to do it here. What's going to happen is you're going to actually do the pop for the first time. When you do the pop, you're actually going to get S2. Agree? So now S states over here will be S2. You got a truncated word at the same time, which means we're going to remove this EOF. We're almost done. So now the state over here is actually equal to, so now it is the case that states is really an accepting states. In that case, we're going to make the state condition here false. So that means we can now go to the if statement over here. Okay? And then, now the state that we keep track of is actually S2. It is an accepting state, which means the R241 we have read so far. Now, we can return the type, which means S2 is actually register. We're basically returning 2 things. We are returning the word, which is the longest matching word, R241, and also the syntactic category. Over there, it is simply just register. Okay, that's what we have. So the important thing to notice is this. That's why I want to do a complete tracing for you. What's really important for you to notice is, given R241, R2, R24, they are not recognized as a register name, but only R241, because that's the longest you can recognize. Okay? Okay? Okay, any questions? Go ahead. That's okay. Go ahead. Actually, the bad state would be important. Okay, let's say this. Just mention very quickly. You might have a string. It's not really this particular example, right? We don't really see the usefulness for the bad states. It might be that you simply got some input string over here. Somehow, you simply, let's say until here, it doesn't lead you to any accepting states. And then as soon as you reach one more character, it leads you to the error states. So far we have not encountered any accepting states. In that case, this string should be rejected. In that case, if you keep backtracking until the end, and now in this case, now you just get empty. In that case, you should only get bad left. In that case, you should reject the string. That's just another case we didn't talk about, but that also works. Mm-hmm. That's another way to do it. I think the textbook, I just follow it. So I think the textbook somehow, they simply put a bat over there, simply tells you, bat simply means the character you have read so far simply did not even encounter accepting states ever. It simply leads you to error state directly. So that's why it should be bad. I think that's what the text was meant to say. Yeah. Okay. As I know it's kind of a tedious, but I think I just want to do it for your knowledge. So what should you know? Basically, you should convince yourself the coding over here tells you it will match the longest sequence of character that's going to match the syntactic category. That's something you want to know. Okay? We okay? All right. Okay, so that's about just to complete our lecture on the scanner. Okay, I will continue with the grammar. Okay. Okay, so today we're just still going to do the review, but I believe there will be one detail you may have not seen in detail in 2001. But from Wednesday, we're going to do something completely new for you about parsing. Okay, that's where we left off from last Wednesday. Okay, and then we talk about this example here. And let me start with this. Basically, let's consider this particular grammar. Okay, we talk about two versions for the programming language. And now I'm got a simplified version, which will somehow fix the ambiguity that we talked about last Wednesday. Okay, let's see. Okay, so now here is our grammar rule. We're saying that expression produces expression plus some term. You can see what's the difference, what the difference is. You can see rather than saying expression produces expression plus expression, we introduce another category for the grammar, which means simply just term. You might call it a different name, but you call it term. And then I say for the term, it can be rather than just term times term. I say term times some factor. So I'm introducing some hierarchy for the level for the tree. Okay? Somehow this will simply solve or remove the ambiguity that we talked about in the two versions last Wednesday. Okay, you can refer to the language there and see how you can address that particular language. I'm just showing you a simplified version. So now what I need to do is to convince you that this one here is going to be unambiguous. Well, we can try the example later. Okay, and just for your information, so all the variable will be expression, term, and factor. And also for sigma, will just be a plus times, etc. Okay, so these are the tokens. And the star variable will just be expression. Don't forget, you should always start with the star variable when you do derivation. Okay, precedence somehow is embedded in the grammar. Now we want to see exactly how this is going to be done. Okay, let me just see this. Okay, let me just talk about this grammar specifically. Okay. You're going to see something very similar as an example later, but let's talk about this one here. Okay. What I will do is, I don't think I got the example just yet. Okay, let me just put it here. Okay, let's say that's a grammar we just look at on the slides. Sorry. Here. That's a grammar we just look at on the slides. Okay? So now, are we going to get any ambiguity? When we say a plus a multiplied by a. Yeah. Are we going to get ambiguity? That's a question. When we talked about the two versions last time, let me to briefly remind you. What we said last time, the grammar was easier in some way. You simply got expression and expression. And also, here, you don't have anything here. You just say expression, also multiply by expression. That's what we got last time, right? And the problem really is, you might actually associate the order of evaluation in a different way. Plus first or multiply first. But in this particular grammar, we know somehow it tells you that it should be multiplication first. Now let's see why. Okay. For now, we're still going to do the derivation manually. But later on, we're going to see some automated process by the parser. Okay, we're going to see that later. Okay, so now, how can we draw a parse tree for this, right? Why don't we do it quickly? I definitely should start with expression over here. Always the root of the tree should be the star variable, which is expression. So now, which production root should I take? Okay, expression plus term, thank you. So expression plus and term. Okay, so now, apparently I'm saying that going to be this and this, right? So now for expression, it's simply going to be term, and then term will be maybe factor, and factor will be A. Okay, and then what about the term over here? Thank you. Yeah, this might be something you have done, maybe in fact 2001. Just review this particular process. Okay, term multiplied by factor, and then term will be to factor, and then factor will be to A, and factor will be to A. So now, okay, this is a unique parse tree for this particular input stream. Okay, there's no ambiguity. You just cannot draw another one. So now, if you want to think a little bit more, if I somehow want to evaluate this particular expression, right? Now it will make more sense. For example, I can simply choose to do the post order. Okay, this term is also mentioned later in the slides. I can simply do evaluation using the post order. In that case, if I do the post order, that means I'm going to encounter this value first, right? And then, what about the right-hand side? The right-hand side for the plus will be depending on the evaluation result of this particular rep subtree. So now that means I have to evaluate this, which is multiplication, and that corresponds to exactly the consistent ordering we are used to, right? So which means you got to evaluate this A times A before you can plus that into A. Okay? So now this grammar is actually fine. So several things for you to note for this particular slide. Okay? Number one, given this particular grammar, I might just ask you whether that's ambiguous or not. Sometimes I might give you a little bit hints. I can say, consider this particular string. Once you see that string, you want to see whether you can draw maybe more than one parse trees for that. If you can draw more than one, that means it's ambiguous. If you can only come up with a unique parse tree like this, in that case, it's unambiguous. Okay, something to note. We'll see a more complicated example in just a moment. Question?
If you change term multiplied by factor to term multiplied by term, is that still okay?
I think this for this particular example, it might still be okay. Yes. So the question was, that's a good question. Of course, it's a very simple grammar over here. The main purpose of having expression versus term is because we want the plus operator to be at a different level as the times operator. That's the main reason. But now within the term, you don't have another operator to be distinguished. In that case, if you simply change this to be term, that will be fine. Oh, actually, term and then factor. Yeah, that's fine. That's fine. Okay, that's not a problem. Okay, good. Okay, guys, since it's the first time we have the assignment, I have a small request. If, for most of you, you are fine. So if you really decide to work on your assignment in the lecture, I would suggest maybe not to do it, okay? But I'd rather you pay attention. Either you can do your assignment outside the class and watch a recording. I have no problem with that, okay? Just mention quickly, okay? Please. Okay, so now let's go back to the slides over here. Okay, just maybe two more basic topics to review about the CFG. Okay, how do we convert from regular expressions to CFG? That can be another nice exercise to do. Okay, so this is simply just some recall actually the meaning for regular expressions. Okay, so now let's just do one example here. If I got this particular regular expression, okay. Let me just copy that on the iPad, and then we'll do it together. And then I got another exercise for you to try. Let me put it down first. Plus 1, 1 plus 0, and then start, okay? The answer is on the slides, but you can refer to it. So now, how do we design a context-free grammar that's going to accept the same set of strings as this regular expression? First of all, it's definitely doable because regular expression can only specify regular language, right? But now context-free grammar can specify something that's a superset of regular language, right? Context-free language, so that's definitely doable. No, not quite, not quite. So here we talk about how to turn your regular expression into context-free grammar. Right? This is different. But this one here is simply say, given regular expression, you want to turn that into grammar, right? It's different.
In some sense, it is related to design because all these three languages would have push down automata, which are really NFAs plus a stack. So you could potentially turn this into an NFA and then not use the stack.
But I don't think you will have to use a stack for the assignment one. Yeah.
That would be the grammar.
Yep. Sure. So now for this one here, how do we do it?
Do it step by step process from top to bottom.
Sure. Since we don't have to automate it, right? Let me suggest one strategy for doing it. Oh, So Mahu, you want to suggest something? Yeah.
Do the left and do the right.
Yeah, exactly. Yeah, in some way you got to do it recursively. In some way you're right. Okay, so now let me show you here. Okay. What you can do is this. I can say I can do one of them. I can do this one here. Let me name that to be, let's say A. I will do another grammar for producing this. Okay? And then I'll do another one, maybe to produce, but kind of the idea. Let me say this is C, and then this is D, let's say. Okay? Let me just put them out, put them down first. So A is going to produce 0, 0. And B is going to produce 1. And C is going to produce 1, 1. D produces 0. Okay? Let's say we have that. Now, how do we do the rest? Let's say this part over here, okay, just this part. Actually, we can do this part as well. Let's say this guy here. How do we do that, right? Let me call that maybe E. Okay. Of course, the way you name the variable is not. You can just have a systematic way to do it by yourself. Okay. So now E over here will be, first of all, what will be the base case for E? Can it be empty? Yes, I agree. It could be either empty, or it can be as many A or B as you like, right? So now I might just introduce one more. Okay. I can see my idea. Now let me just call it F. So F will just be basically A or B. And in that case, E will be simply maybe F and E. You can have as many as you like. Everybody okay with that? Okay, follow the same logic. Let's say if somehow eventually you can also get another one here, just call that maybe G. So now I got E and G. So now finally you have a star variable here, and then say either E or G because of the plus over here. That's kind of the idea. It's not very difficult. You just have to be careful, the pattern. Okay? It's kind of different from what you will see in the slides, but it's the same solution. Okay? That's the one model solution for doing this. Okay? Questions? All right. You want to do a quick exercise on this? Quick exercise. This is something you saw from the previous regular expression. You may reuse a variable if you wish. If you see any pattern repeating, you may. Give it a try. Okay, this is not a difficult one. If I may suggest, just we can have more similarity on our answers. How about we say, for this part here, I'm going to name it, let's say A. And this part, the same pattern, I also name it A. How about that? Okay? And then for, almost giving out, that's okay, just B. Well, I'm basically helping solve it. I'll write it down as well on my iPad. We'll solve it at the same time. Okay. think the only thing you have to be careful is quite a simple one, so that's why I don't want to spend too much time. Just do some exercise together. The star, you got to be careful. Okay, I think your answer should be more or less like mine, right? More or less. Basically, you can see the star over here, right? You will see over here C. I'm saying this particular cleaning star closure over here is C, right? First of all, it could be empty string. It can be as many repetition for A. What's A? 0, 0, 1. Okay? Questions? Go ahead.
Is B necessary?
Is B necessary over here? Oh, actually, good question. I would say if you're just doing this manually, no, it's not necessary. But when you are doing possibly some like an encoding programming, you might consider it as necessary. Depends. No, for the test, you could have. So Ms. Gov asked a very good question. So let's say this. I could have done the following. I say rather than having B over here, right? I can simply put 1. That's not a problem. Okay, that's okay. Just for me, I like to name every pattern, right? Yeah. All right, guys, any question about this? It's kind of easy, right? Okay, not easy, but straightforward. Okay, the next one to review quickly is about given DFA, how do you convert that into context-free grammar? Did you guys do this in 2001? Oh, let's do it. Let's do it. This, huh?
Can we just convert the DFA into regular expression and go from there to context-free grammar?
Yes, in theory. What Mahmoud just said was we can go from DFA into regular expression and then use the same approach to context-free grammar. But we didn't quite cover, we didn't quite review from DFA to regular expression. So I can assume you actually know it, right? How about we just go with this approach here? But you're right. If we did cover that, I wouldn't bother you with this. Yes. Okay. Okay. Oh, I'll just give you one example. You will see certain rules over here. Okay. For the rules, don't worry too much. Okay. I'm gonna just do it together with you. Okay. What I will do is let me just show you the answer for this particular one, and then we'll do one example together. Okay, just let me just copy this guy here to my iPad. Okay, I didn't prepare this page. Okay, let's take a look at this one here. There's just certain rules you gotta pay attention to, and then we'll do one example together. Okay, that's the one. Okay, basically, every state should be a variable. Okay, so now we're basically saying R0 is representing R0 here, right? S0 over here. R1 is representing also S1. And because S0 is actually a starting state, right? So that means R0 here should be set as the start variable. Okay, that's very straightforward. Now, how do we encode the transition? Very easy. Basically, by taking 1, you can go back to R0. 1, go back to R0. Okay? If you go for 0, you go to S1, so go to R1. Easy. Okay? And similarly, you got the other two transition here, either go for 0 or 1. And now, how do we encode an accepting state? That simply, it can simply stay there. Okay? Epsilon. Epsilon tells you that R1 represents an accepting state. Which means you don't need any further derivation, just epsilon, no more. Make sense to you, guys? Okay. Why don't we do one exercise together?
So basically, you convert the determinant function
Into a rule.
either to the left or to the right.
Oh, actually, the left are simply corresponding to your states. And then these guys over here are the transition, yes. And this guy here is specifically for accepting states. You cannot put epsilon for every variable. You cannot. Okay? Guys, do you see, you actually see wide epsilon over here, right? For example, just in case, right? I'm just worried, in case. So now, if I simply say R0, okay? And then R0 can definitely go to 1, R0. That means we're not done yet, right? 1 R0 can then go to, oh, you know what? Let me go to 1 R1. R1 over here, let's say I go for this one here. And now what about R1? And then R1, it could be, for example, just epsilon, which means just epsilon here. So that means 1 should be accepted. Oh, sorry. Beg your pardon. Sorry, 0 R1. Okay, sorry about that. Yeah, I was contradicting myself. 0, okay, 0 should be accepted, right? Good. Okay, 0, taking that, accepted. Okay. So that's why epsilon should be there, but not for every variable, unless every state is accepting state, unless. Why don't we try to sketch this guy here? Oh, don't worry, don't do it. Actually, it wouldn't take you long if you know the pattern already. Okay? Okay, first of all, how many variables do you need? 6. Okay, I agree. Okay, what about for simplicity? I'll make every variable just the same as the state name, let's say. Okay? I got S0, S1, S2, S3, S4, S5. Okay? And then, of course, every one of them produces something. Okay? Let me tell you how I would do it. First of all, which one should be the start variable? 0. Good, thank you. Okay, that would be a start variable. In the quiz or in the exam, you just tell me which one it is. That'll be okay. So now, think about this. Which one should have an epsilon production?
S4 and S4.
S3 and S4, right? Did you say S4 and S4? Oh. Yeah, okay, epsilon. The rest will be obvious. Let me just do one, okay? How do I do, for example, how do I do for S3? Let's see, okay? S3, so that'll be or. If I go for 0, go to S1, and then if I go for 1, go to S5. It's pretty easy, right? Okay, you got the idea.
S5 is terminal state. It's like a dead state.
It's more like a dead state, yes. But that's the input you're given, right?
Yeah, so you.
So it's 0, it's 1 S5, 0 S5, 1.
Yeah, the same. Yeah, so that'll be for S5, just for your information, 0 S5, and also 1 S5.
Do we need a death state automatically terminating the tree?
Sorry, say that again.
Do we need a death state if it's automatically terminating the tree?
You don't need, not necessarily. For example, if you look at the previous DFA, there's no death states. And it's still terminating. Basically, as long as you have an accepting states, meaning that at least one of the production is going to give you some reachable production. It's going to give you epsilon. That means you cannot terminate. You don't really need a death state to terminate. You don't need it. Okay. Okay, guys, you got it? Okay, that's good. Okay, let's continue with the discussion. So these are some easy exercises you should really try to get familiar with. Okay, let's go back to the slides. Okay, so now we want to talk about derivations. I want to just define ambiguity a little bit more carefully, right? So far, the way we define ambiguity is for the given string, if you can find more than one parse trees for that, right? Then that'll be ambiguous. Let's talk about this particular grammar, which we talked about already, right? So now we want to refresh your memory about how to do derivations quickly. Okay, we'll just do 1 or 2 together, okay? So there is something called a leftmost derivation, okay? So now, for this particular grammar, we know that it's unambiguous, okay? It's because for any input string, for example, a plus a multiplied by a, okay? You can only have a unique leftmost derivation. What does it really mean to be leftmost derivation? For those of you who might still remember. Yeah, well, it's quite obvious, right? Yeah. Every time when you want to do derivation, always consider the leftmost variable. That's basically what it is saying. Okay, why don't we just do 1 together and you get the idea. Okay. Let me just go to iPad over here. Okay. I got many others, but I'll leave them as exercise for you. Okay, you should try. Okay, let's just do 1 together just to get some idea. Okay, let's say we have basically a plus a multiplied by a. So I want to do derivation. Okay, we'll definitely start with expression. Of course, in this case, I assume that I already told you. The expr is a star variable. So now let's say this. EXPR, okay? What's the leftmost? EXPR. Easy. Okay, so now we should choose maybe expression plus term. At the same time, I'll try to do the parse tree. Plus term. And one thing I want you to think about before we reach a conclusion. As you can see, for the leftmost derivation, we are trying to choose the leftmost variable to do the derivation each time. Is this particular order going to be reflected on the tree? Meaning that later on, if I give you some parse tree, are you able to tell how I got to this tree? Are you able to tell I actually did a leftmost derivation, or did I do the rightmost derivation, or did something else?
Well, it depends how you read it, because you said poster, so it's always going to
Nope, I'm just saying I give you a tree. Depends on the grammar? Depends on grammar?
Do we have to just check that the first thing is to the left? The first thing with the tree is to the left? Like to the leftmost derivation, you have to start from the left. So just check that.
Not quite. We will see for the same input string over here, you can actually do leftmost derivation. You can also do rightmost derivation. It will actually give you the same parse tree. Oh, we're just saying for this particular grammar, just in general. Yes. Yeah.
Because you're supposed to get a unique tree every time.
Yeah, unique tree every time. So now, so that means it shouldn't really matter whether you do leftmost or rightmost. Okay, but when the grammar is ambiguous, you got to be more careful. Yeah. Okay. Good. Okay. So now let's say this. Okay. So now, given this, we should really do the next one should be expression here, right? So now, for expression, we should really say any suggestion? Turn, right? Turn first. Thank you. Turn plus turn. And then again, this is leftmost. And then turn will be factor. Thank you. Plus turn. Okay, and then this will be factor and then to A, right? Okay, A plus turn. So now you can see A is now terminal. Plus is also terminal. So now the leftmost is actually this guy here, turn. Okay? So now we should really say A plus. So now for turn, well, I know it's going to be turn multiplied by factor. Okay? And now the leftmost is the turn. Okay? So that would say A plus. So now for turn would be factor. I know it's a bit tedious, but just got to get it right. Okay, factor over here, and then A plus A multiplied by factor. Okay, and now for factor over here, it will just be A. I hope I didn't miss anything. Was it good? Okay, thank you. Okay, only do this once, okay? But now, this is a derivation, okay? If you see the slides, let me just get the terminology agreed. That's the leftmost derivation. The next one is to do the rightmost derivation. I rely on you to do it, okay? I trust you. Otherwise, you got to do it the first time in the quiz or in the exam, either way. Okay? Just do it quickly. Okay, this is just another derivation here, but now we chose to do the rightmost variable each time. Okay, now you can do that easily. Okay, so now if you compare this particular derivation here versus this derivation here, they are considered as different derivations because you can easily find a certain step where the mix of maybe the, maybe not this here. Okay, for example, you'll find certain line, for example here, you'll find that this line here does not correspond to another line in the rightmost derivation. They're simply not the same. So we say that the two derivations are not the same. But now, having two different derivations for the single string, you cannot conclude the grammar is ambiguous. That's the point I want to make. So when you want to conclude, okay, what I want to say here is, given input string, let's say W, if I can find out derivation 1, derivation 2 for W. And somehow these are different derivations. Let's say that's all I tell you. Okay? Can I conclude that the grammar G is ambiguous? That's an important concept to review. I'm saying the derivation here, I'm just saying I give you some derivation, which might either be leftmost, it might be rightmost, or maybe just arbitrary order. There's another derivation there, just different. Somehow I got at least 2 different derivations for the input for the same input string. Can I then conclude G is ambiguous? The answer is simply no. Because if you look at the previous example there, the rightmost derivation and the leftmost derivation, they are simply different, right? They're doing the order differently. But now their parse tree will just look the same. Okay? So now we're going to go to the definition for ambiguity in just a moment. Okay, so now that's important. And then there's one more thing I want to mention. So this is just another input stream over here, for which you can also practice doing the leftmost versus rightmost derivation. You can see it's not difficult. You're just going to be careful. Don't skip any steps when you do the derivation. Of course, you will hope there's a way to automate the process of finding the derivation, which is what the parser will do. That's something we'll cover very soon in the course. You got to think about different approaches to parsing. Okay, I'll leave that to you. There's just one more thing I would like to point out. Okay. Basically, for these 2 strings over here, okay, do they have the same parse trees? I heard yes. Anybody would say no, maybe? Okay, actually different, okay. Chelsea.
One of the rights, since you have A plus A brackets, could you consider its left term to be a factor as a factor?
No, actually, when you do this, okay, I'll just mention quickly. Your question might be, I'll switch to iPad in just a moment. If I want to, you can also double check the slide for answer. Okay, I'll just mention quickly. If you actually want to do A, so how do you actually end up having this, right? Basically, apparently this is the leftmost terminal you want to get into. So you want to make sure you do your leftmost derivation in a way that you will derive this particular A first, and then followed by this A, and then followed by this A. That's what you should really see in the leftmost derivation, just mention quickly. Okay. And then I want to say the following. If you look at the parse tree over here, okay, that's already there, according to the grammar. First of all, convince yourself that those are really different parse tree for yourself, right? First of all. And now, number 2 to notice, we'll see more example later. Since there are different parse trees, so which means when you try to process them, you have to process them differently. So that means they got different meanings. They got different semantics. Okay? Every time you got different parse tree, that means you might just handle them differently. So now, another example for you to think about is like this. A plus, I'll switch to iPad in just a moment, exercise for you. Okay, that looks very easy conceptually, but I want you to think about in this way, okay? Exercise here. Consider expression number 1, expression number 2, and expression number 3, okay? Do they share the same meaning? According to the grammar G that you were given. Okay, that's a question. Okay, so whenever you see meaning, that's really mean the shape of the parse tree or abstract syntax tree. Okay, hopefully you will find that because our grammar is unambiguous, you'll find that without the brackets over here, it's as if we try to put the brackets around to multiply. So these 2 should really share the same meaning. Maybe meaning 1, and this will be just another meaning. Just different tree, meaning 2. Okay, that's something for you to think. Raymond.
But 1 and 2 will have different trees, right?
But when you actually try to traverse them, you may want to do the post-order traversal. You will see that it will turn out to be the same.
Okay.
When you do the brackets over there, yeah. Because brackets just force the order of evaluation, yeah. That's kind of of course, the thing you got to deal with when you do your projects later, or possibly some assignments. Okay. Try the exercise, draw the parse tree, and then you're right. The 1 and 2 might look different. However, if you think about the post order, you're gonna to do evaluation, they turn out to be equivalents. Okay. That's why I say the meaning are the same. Okay, let's define over here quickly. Okay, so now that's something I just mentioned already. Okay, just review quickly. When I have distinct derivations for any string, does that mean they got distinct parse trees for W? No, right? Because it depends on the order of the substitution. So this question is the most important one to make sure you actually refresh your memory about. Okay, you might get the same parse tree, but you may not. Of course, just in general, you cannot say the implication holds. Okay, for example, you will see that over here. Well, basically, that's just reviewing what we said previously. Okay, just review this sentence here. Okay, you will see the example. Okay, so now for ambiguity, we say the following. You will say that a string is ambiguous. Well, is derived ambiguously from some grammar if there are two or more distinct parse trees for that particular string. That's one way to say it. Okay. Or you can say two or more distinct, either leftmost or rightmost derivations. So Chelsea.
It's not that the leftmost has to be the rightmost. It means that if you have one string to two different leftmost derivations, you have two different derivations.
Exactly. Either you have to, maybe I should really make this slightly a bit more clear. Either you have distinct parse trees, number one. Number two, you have distinct leftmost derivations. Number three, you have distinct rightmost derivations. These are the three. I'll modify the slide to make it even clearer. Yeah.
You solved that problem because you don't have two terms.
You mean for that particular grammar? Yes, we solved the problem by removing the ambiguity using turn and expression, right? Two different levels for plus and multiply. I think for our case, we're not really talking about to decide this, automatically. We're just saying, given a particular grammar, can you find a string? But just by definition, right? You're saying deciding whether the grammar is ambiguous? I'm just saying, in order to show a grammar is actually ambiguous, you simply show an input string such that you can find, different cases over here. But how to solve that problem there, we didn't really say how you can solve it, which is by giving examples for now. Yeah. Unless I want you to really program a function to say, taking the grammar, return true or false, right? Whether that's ambiguous or not. That would be, yeah, exactly. So that's my point. So here, we're saying, given some grammar as an example, I'm just showing you one string right away to show that it's actually ambiguous. It's a different things we're trying to do. Yeah, but it's a good point. Yeah. So if I do give you, let's say, assignment number 2 to say, now program a Java method taking a context-free grammar and decide whether that's ambiguous or not, you should really reject right away, right? Say, no, it's not doable, right? Of course. But don't do it. Okay, anyway, so make sure you understand this definition here. I will try to rewrite it in a slightly clearer way, and I'll update it tonight or tomorrow. Okay, guys, any question up to now? Yes, you first, and then Coco. Yeah.
Earlier, you changed term multiplied by factor and multiplied by term. It's not ambiguous.
It's not ambiguous. Yeah, it's not going to make it ambiguous.
But then what if you have
Oh, you mean saying the parse tree would be different, right? Interesting. Very good. Yep, apparently I'm not very good thinking on my feet. I'm very poor in that, actually, to be honest. That's okay. You guys are better than me, which I'm happy. I don't mind. Okay, let me try. Okay. All right. Okay, let's try this. So here's an exercise for everybody. Okay, you're saying the following. Let's say we simply do, let's say, so for this part we are okay, right? Okay. Oh, sorry, here. So for the expression we are fine. It's mainly the term, okay? What if we simply change this guy over here to be term? That's what you're saying, right? Let's try, okay? I'm not too sure, okay? If you say, for example, A multiplied by A multiplied by A, is it possible to get two different parse trees? Is it? Let's try. I might say expression over here, okay? And then I'll simply get term. So now I might say term, or I'm going to say term, and then multiply by term. It seems like it's possible, right? So now either we want to make this guy here, we either group this way, or we group this way. Then we get different shapes of the parse tree. Everybody got the idea? So you're right. In this case, it is ambiguous, according to the definition. Even though, if you try to apply the multiplication in the post order, you might just get the same result. But it doesn't matter. What really matters about the definition of a grammar being ambiguous. If you get a single string that can get two different parse trees, then that's ambiguous. Okay, good. I'm glad we clarified this.
Well, also the thing is that
Yes.
we're defining that so yet going back to the thing that I was saying, that like it's undecidable to
Yes.
check whether it's ambiguous or not. How would we actually
Yeah, I would.
when we design our grammar? Because it's simple.
I think yeah.
Programming language.
I think there will be certain classes of errors the compiler can find out to tell you. Not really. There will be some common categories of ambiguity that is compiler can automatically detect, which you will see. Yeah, but let's save that a little bit. Yeah. So what Ashkan's question was, if the problem for deciding if a given grammar is undecidable, then how can a compiler generator do about it? I tell you what, somehow compiler generator will tell you your grammar somehow to some extent is ambiguous. Certain classes of errors, we'll see that. Yeah. Maybe that's good for now. Just
The simple pieces that I know you
yeah.
get back, but
In general, no.
you're still going to have
I agree. In general, no. Potential issue. That's true. That's true. So you're going to do some testing and make sure for all the cases you can think of, you don't run into issues. You're right. Okay. Okay, are we okay with this example here? So guys, this will be just another exercise here. If I simply give you this grammar over here, is it ambiguous? Yes, it is. Coco.
So I have a question about the derivations. When you
Go ahead.
do
Mhm.
derivations,
Yeah.
you just make the final result, or you make the whole.
Oh, good question. So if I really ask you to do in the quiz or in the exam, for example, okay, I'm afraid, for example, let's say this. One example here. We'll get it. Oh, we got 5 minutes, got it quick. Let's say, for example, if the quiz question was something like, given this grammar here, I say now do the rightmost derivation for this particular string, okay, if it's doable. Sometimes I might give you a string that's not doable, in which case you're going to tell me it's not possible. Okay? Okay. If it is possible to do so, of course, you have to show me everything here. I'll be a little bit lenient. I would say if somehow you're missing some step, I'll just deduce some marks. I wouldn't say if you simply miss one step and the whole thing is wrong. No, not really.
And that's for afterwards we said that the derivations are equal or not. That was the question.
Oh, those are the questions. Okay, you know what? To really make the point explicit, if you can bear with me, let me just make it very explicit. I should have prepared this, but I didn't expect this. This is rightmost derivation, right? Okay, let me just do that here. If I put two things at the same time, okay, this is the first one. Bear with me. Okay, this is the rightmost derivation for that one, right? Okay, let's do another one quickly. So to make my point. And then if I got the leftmost, okay, I'm just gonna copy and paste it, and then we'll compare. Okay. Okay, and then let me paste this guy here. Okay, that's the leftmost. So now, are they the same derivation? Basically compare, like a comparing sequence, right? For example, as soon as you find out anything that's not the same, for example here, 3 and 3, they are not the same. So they are not the same derivation. However, that's a good point, because now, given the same string, now I find 2 different derivations. Can I make the conclusion that the grammar is ambiguous? No, I cannot, because it's not fair. You got to make sure the order of doing derivations is exactly identical between the 2 iterations. Let me write it down, and I'll take questions. So now, this does not imply, okay, the grammar G is ambiguous. Does not imply, okay? Because the 2 derivations not done in the same way, in the same order. Is that okay, Coco? Is that okay? Good.
The grammar and the chopping of something. Is there a situation where this implementation would work? Like you can't come up with a
Let me think about it. Yeah. As you know, I'm very bad in thinking on my feet. I don't want to give something that I gotta withdraw later.
I was asking if you could such a result.
I don't have immediate answer right away. Yeah. Let's talk after class. Yeah, I'll like to think about it. Okay. Good. All right. Okay, so now let's go back to the slides, and then unique rightmost. Okay. Parse tree, and then that's about the definition for ambiguity. Okay, we are okay with this. Okay, so now we got exercises for you. Okay, this one's rather easy. I'll leave that to you. Think about this might be something I'll give to you again. I'll give you some simple one, right? You can hopefully can easily come up with some input string. I would say very likely if I ever give you grammar, most likely it's ambiguous. Of course, it might be that it's unambiguous. You got to tell me you don't think that's ambiguous. I'm just saying more likely. Okay. Okay, this one I'll leave you to do. That one's rather easy. We'll do second one quickly. Okay. I only got about a few minutes, but at least we can see what the problem is. You can think about it. Oh, question for you. I don't think any one of you was doing 1022 with me. Oh, you did. Okay. Okay. Remember in Java? Okay, no. No, okay, that's too long ago. Given that there was also a strike in the semester, right? So I wouldn't blame you for that. Huh?
You said remember in Java.
Yeah, remember in Java, yeah.
Maybe we recall what
Still ask the question.
No worries, that's fine, that's fine. Does anybody of you hear about something called dangling else?
Yes.
I'll write it down before you say anything. I think this one might interest everybody, but we might discuss in detail next time. But I just want to mention quickly to you. It's called dangling else. Have you heard of it before? No, not really about, I can tell you it's something to do with ambiguity.
Oh, is it where it's like, it can be either one to anything else?
How about this? I'll write it down, something like this. Let's say we have, yeah, Chelsea.
Is it that like some like the else statement specifies some other condition that's not?
Okay, let's write it down. Okay, I'll write down what it looks like, and then we are done. Okay, give me 1 minute. Okay, let's say we have if then else statements. Okay, if I say if something here, then I do something, right? If I say if again, then I will do something here, and then I'll say else. Like that. Let's say for our particular language, you don't have and. Doesn't really matter. Now, the dangling else problem, they expecting algo 60. I don't think anyone has programmed that, because even myself, I haven't. Have you? Algo 60? It's basically the ancestor for block syntax. Anyway, so now the question is, when you have programming syntax like this, should this else over here belong to this if, or should it belong to if over here? Okay, how about I would say 1 here and 2 here? Which one should it belong to? Just intuitively, right? I heard, okay, I can tell you that somehow if you do similar stuff in Java, it's actually number 1. Okay, however, on Wednesday, we're going to see some grammar to begin with to see how ambiguity might occur if your grammar was not specified properly. And then we'll see how to improve it. Okay, that's what we'll do on Wednesday. Sorry, say it again? That's, yeah, that's another story, yes.